Sun crawls in through a tear in the blinds. Coffee's cold and I'm out of my mind. Lipstick stains on the cigarette tray. Ain't no angel, never claimed I'd stay. I talk to ghosts in the kitchen light.
Good morning, everyone. That song is stuck in my head, and I'm sure many of you have already listened to it. That song is composed by ChatGPT. The music is by Suno AI, and it has got 15 million views across the digital channels. It is in the top 50 viral in Spotify. Like the poet William Blake once said, what is now proved was once only imagined. And that is exactly what is happening in technology. Imagination turning into reality. If I go back to 1988, that was the time I first stepped into a computer lab. There were rows of these bulky desktops humming softly. I was handed a 5.25-inch floppy with 720 KB of storage. And it would take a long time to compile a program. You could literally take a walk and come back, waiting for a program to compile. If I fast forward to today, 2025, and I look at an Apple Mac M5 Pro, this has a processor which has 10 cores. Each of these cores are 768 times more powerful than the 80286 chip that we had in the IBM PC 80. The memory is 131,000 times more. The storage is around 419,000 times more. The transformation is immense. When 4 years later, when I was doing my final year project, we used to do a 1-year project and submit a thesis at the end of it. My thesis in 1992 was on artificial intelligence. And we were trying to teach the machines how to think like human beings using something called a cognitive approach. One of the things that I remember was teaching the algorithms the principle of uncertainty. So how do you measure uncertainty and put it into a program so that it behaves like human beings? Those days, we used to build knowledge bases and inference engines so that you could come to a decision. We also started dabbling in something called neural networks. And neural networks in those days used to process a lot of data and come up with patterns, the precursor of what we call machine learning today. During this period, I also started a correspondence with Dr. Bruce Buchanan, professor of computer science at UC Berkeley. And he said something very prophetic. He said that the true power of AI will manifest around 30 years later when we will have enough compute, enough memory speed, and enough storage to do justice to the complexity of the processing that we need to take care of. In 1994, when I joined the workforce, we used to have what we called EDP departments. So what the EDP departments used to do is process electronic data. computing was still in its infancy. You'd walk into this room and there would be an entire hallway which would actually house the mainframe. In the diagram that you see up there on the right, you see a 5 GB storage with its controller. It would entirely fill up this whole hall. There has been an immense amount of transformation since then. In the 1990s, Microsoft came up with Windows 95 in 1995. And we started seeing more what we used to call graphical user interface, or GUIs, instead of the green screens that we used to see in our early days. The internet also started coming up. In the 2000s, we started seeing mobile phones become popular. The one you see in the screen out there is the Nokia 3310. I think each one of us had one in our pockets. Extremely popular. The World Wide Web also came into being. In the 2010s, we started putting on our wearables. So it used to collect all the data and load it up into something called the cloud. So the cloud became an everyday term. In the 2020s, AI came back with a bang. And if I look forward, computing, we talked about the IBM PC-80 to the Mac M5 Pro. Computing is literally going through the roof with what we are calling quantum computing and 6G and 7G. But the AI that we have today is very different from the classical AI that was there in the 1990s. We have two forms of AI which are doing the rounds today. One, of course, is generative AI. And I don't need to speak about generative AI. We started with generative AI. And all of you use ChatGPTs, Perplexities, Copilot, and so many others to create content. And it is an extremely useful tool for marketeers, for creators, for educators to create and disseminate content across text, images, audio, and video. The other form, which is also becoming very popular nowadays, is agentic AI. And agentic AI is where you have AI which can think and it can act in sometimes small ways, like scheduling a meeting or approving a task. What is more interesting is different agents or different kind of agents can come together and perform a complex task. So now you have AI which can think, which can create, and which can act. And if I move further into the future, all these forms are going to come together to drive more meaningful human-like interaction. So we are going to have AI which is not only transformative, but also can act and do things pretty much like human beings do. There are three trends that I want to talk about. The first is multimodal AI. Multimodal AI is a form of AI where you have different forms, like you talked about text, images, audio, and video, but where you process everything together and in context and do a task. This has immense amount of application in the real world today. Virtual assistants, which can hear you, see you, listen to you, take your inputs, and create something or do something for you. It could be in the field of medical care, where AI could actually look at medical reports, it could look at medical images, and then create a diagnosis which is very accurate. In the field of education, where you could have digital tutors, which could create content after going through an enormous amount of material which is out there in the market. Autonomous vehicles, where you could have the camera feeds, the GPS data, and the radar data, and fuse it into somewhere you can take real-time decisions. So multimodal AI is going to change the way we are using AI in the future. And coupled with this is the second trend. The second thing is what we call embodied AI. Embodied AI is nothing but AI which has a body. So, which allows AI to sense through cameras and through sensors, to move by using wheels, motors, or limbs, and to act, grasping, speaking, and navigating. So how this changes the world is that now AI can not only learn from the data that you feed into it, but can experience the world by itself, learn in the process, and do things autonomously with minimal human intervention. Which takes me to the third point that we should be cognizant about. The third trend in AI is what we call ethical AI, where AI is explainable, accountable, and can act with what we call digital empathy. So we have to teach our machines not only to think and act, but do it within a moral framework. AI that respects human rights, avoids bias and discrimination, protects personal data, and is accountable and explainable. Now, what you see in the screen up there are two of my favorite examples. The one on the left is a vacuum cleaner. This is the latest one, Robotic Soros Z70. Many of you possibly have it at home. So it can clean itself. It can move around on its own. It is autonomous. It can come up to this carpet, lift itself up, clean the carpet, go back to the floor, and start mopping once again. And if there are socks which are lying around, it can pick up the socks, put it in the corner, pretty much like a human being would do. On the right, you have Tesla's robot, Optimus. There are remarkable things that this robot can do. There it is taking a yogic posture. It can jump. It can do gymnastics. It can also sort color blocks. There are a variety of these kind of interventions which are coming in. And what is happening is, with this technology at our hands, we have great power. And with this great power, of course, comes great responsibility. From the day I stepped into the computer lab in 1988 to today, there has been a remarkable transformation. We have been building thinking machines, and the future will be far greater than that. Just to give you an example, if I take a quantum chip today, if I look at quantum computing, it can break a 8-alphabet password in 7 seconds flat. It would take a GPU with 1,000 crores to do it in 18 hours. It would take a conventional CPU hundreds of hours to break that code. So that is where we are going. In terms of network speed, 5G is 10 GB per second, and we are moving to a world where we'll have 7G, which is 100 GB per second. So we have enormous capabilities at our hand. So the question to all of us is not what can machines do. The machines, believe me, in the 2030s can do almost anything it wants. The question is, what should it do? And that, my friends, is a question for all of us. Thank you.